Types of ultrasound machine. The choice of which type of image to use depends on the goals for a particular test, the phenomena being investigated, and what equipment is available. So, let's get started. Number 1. 2D ultrasound. The most common in type of ultrasound picture is a series of flat, two-dimensional cross-section images of the scanned tissue. Referred to simply as 2D ultrasound, this mode of scanning is still standard for many diagnostic and obstetric situations after a half-century of use. Number 2. D ultrasound. In recent years, 2D ultrasound images have also been projected into three-dimensional representations. This is achieved by scanning tissue cross-sections at many different angles and reconstructing the data received into a three-dimensional image. A common use for 3D ultrasound pictures is to provide a more complete and realistic image of a developing fetus. Number 3. 4D ultrasound imaging. By updating 3D ultrasound images in rapid succession, sonographers can also create 4D ultrasound pictures. In the 4D ultrasound, the fourth dimension, time, adds movement and creates the most realistic representation of all. Number 4. Doppler ultrasound. Evaluating blood flow as it moves through blood vessels is a common component of many of the types of ultrasound. While traditional 2D ultrasound and its three-dimensional offshoots show internal tissues and structures, a different kind of ultrasound is required to evaluate blood flow and pressure within a blood vessel. A Doppler ultrasound analysis bounces high-frequency sound waves off blood cells in motion and records changes in frequency of the sound waves as they echo back to the transducer probe. It then converts this data into a visual representation of how fast and in what direction blood is flowing. Doppler ultrasound is an indispensable diagnostic tool in all areas of ultrasound testing and is preferable in many cases to X-ray angiography, because it does not require injecting the patient with contrasting dye. 3 types of Doppler ultrasound are currently in use in addition to routine grayscale imaging. Of these, color Doppler uses a wide choice of colors to visualize blood flow measurements and embed them within a conventional 2D ultrasound of tissues and structures. This provides a more pronounced representation of blood flow speed and direction than is the case with traditional grayscale images.